Hello Calculus 2 students. Let's have a review session, and I'm going to use an actual problem set I used several semesters ago. Okay, here we go. The problem is structured like this. We have a bunch of antiderivative computation problem, indefinite integrals, and then some improper integrals, areas and volumes, and some Riemann sum problem. Okay, here we go. Let's go to my notebook and let's talk about these here. Okay, this is an elementary problem. It's typically integration by part problem. We have a monomial rather, times cosine, and which one has higher tendency to become u, and which one v prime. That's basically it. It turns out that sine and cosines have higher tendency to become v primes, and power functions have higher tendency to become u, comparatively speaking. So that's what we're going to get. U, v prime, u prime, v, okay? All right, and then let us put everything into integration by part formula. U times v, so u times v, that's what we get. And then u prime, and then v. So u prime and v. After that, just simple computation. This, and then 1 times sine of x, so you just have sine of x. So calculating the antiderivative, you get this. It's virtually a giveaway problem. If you know integration by parts formula, you can handle it easily. Next problem. This is going to be an integration by parts as well, but it's a little bit harder to see because we have cosine squared here. However, by this time, you should remember that cosine squared can be reduced down to just single power using the half angle formula, or double angle formula if you want to call it that way. In short, cosine squared can be written as 1 plus cosine of 2x over 2. And this way we have just single power. This, let's just break up these, and then we have 1/2 of x, and then 1/2 x times cosine of 2x. Okay, this part with integration by part. This part, easy computation. The other part, now that's the integration by part. Okay, let's do this integration by parts. U v prime, and then u prime v. Make sense? The power function part is u, and trig part is v prime. And u prime, we have 1/2. V sine becomes cosine, the other way around. Cosine becomes sine, but you have to be a little bit careful about this coefficient. Okay, let's put everything into the integration by part formula. U times v, and then u prime v. So after a bit of a simplification, this is 1/2 times 1/2, so 1/4, and then sine of 2x, so I need another 2, so I have 1/8 down here. And that is the antiderivative computation for this part. So putting everything together, you get the answer. This part done, and the other part we use the integration by part, like this, and then we get that. Basically, this is a kind of problem that you can easily see if you see cosine squared going down to this, and then just routine integration by part. Let's go to the next problem. I intended this problem as an easy problem, really easy problem. How do you handle the denominator? It's a complete square. So what do you have? We have x minus 2 squared down here. So this is a power function. negative second power. So the antiderivative easily follows from the power rule immediately. Okay. Next problem. Now this time you have to do some factorization to the denominator, and that'll lead to the decomposition by partial fraction. Okay, let's go. We have 1 over this quadratic trinomial, factor it, and then you see, let's forget about this part for the time being, and then you have this factor and that factor, so you gotta have subtraction. So 1 over x minus 3, 1 over x minus 1, start from there. And if you take common denominator, so we have x minus 1 over x minus 1, x minus 3, and then x minus 3, and then we have x minus 1, x minus 3, if you take common denominator. So basically what you get is x minus 1 minus x minus 3. If you do it right, you're going to get 2 over x minus 1, x minus 3. Denominator stay the same because this is basically x minus 1 minus x minus 3. So you get 2. And how do you undo this 2? That's where this 1/2 is coming into play. Okay, once you see up to here, now that's easy. This is a log function, and that 2 is a log function. And there goes the antiderivative. It's okay to put these two logs together, but my default is just leaving as they are, and that's what Mathematica does as well. Finally, how about this? Kind of similar denominator, 4, 3, and now 5. How does that work? Can you factor this? No, you can't. It'll turn out the denominator is irreducible. In that case, you take the complete square, and you're going to end up with arctangent function, like this. Take the complete square, and this part is complete square, x minus 2 squared plus 1. 1 is 1 squared, so you can use the, no, you don't need 1 squared, excuse me. This is the derivative formula for arctangent function, so you just get arctangents of x minus 2. So much for the antiderivative problems.